All right, this continues our lecture on how to solve for a single variable. This time around, we're going to be doing both the addition property and the multiplication property. So you see the R highlighted here in this formula that we want to solve for. So the first thing that's being done is addition property. I need to get rid of that addition property. So I'm going to move the P that's being added to my variable by using the addition property of equality. I'll add its opposite to both sides. So now I have A minus P is equal to P times R and then times T. Now again, I have P and T, right, that are actually associated and commuted and associated, so those are the numeric coefficient of R. So I'm going to get rid of those with the multiplication property. So I'm going to multiply by the reciprocal of PT. Now, usually when we solve for a formula, we just put a carte blanche over here, a denominator of PT. But because of what we need to do with solving linear equations in two variables to put them in slope-intercept form, I'm going to divide each term in this side by the PT. And that's to help us out with what we need to do with these equations in algebra, which is slope-intercept form. So now I have R, which is what I'm after, is equal to A divided by PT, and then that is minus, and here, the P here and the P here cancel, which leaves me a 1 up here and a 1 down here, and so this is a 1 over T. Now this is my preference for how this will look. In green here, I'm going to write what books will usually write for their answer. They'll simply say that R is equal to A minus P, and then they'll simply say over PT. Now, one of the things that I want you to realize is that it is not possible with A minus P up here to cancel this P and this P. There is no canceling in addition, and I want to warn you against that. Please do not make that mistake. All right, let's look at part D here. In this one, again, we have multiplication by the H, and then we also have addition. It's the addition property that comes first. So we're going to want to undo this addition of 2 pi r squared. So I will add the opposite of 2 pi r squared to both sides. And then, once I do that, I have S minus 2 pi r squared on this left side. And that is equal to 2 pi r h. And just like I said before, in this case I'm going to multiply by the reciprocal in order to get rid of this, but on the right side, or on the left side, I'm sorry, on the left side of the equation I have two separate terms, so I'm going to divide each single term by this 2 pi r. Not just the whole entire thing, but your book's probably going to show you the whole entire thing. But again, I'm interested in our application for slope-intercept form. Now when I do this, I get H is equal to, and S divided by 2 pi r, that's just going to look like it does, S divided by 2 pi r, and then minus, and then here the 2 pi and the 2 pi cancel. And one of those goes with one of those, so I just end up with minus r. And that's what I'm going to show this looking like. So the s in the numerator there, and my over 2 pi r, and minus my r. And that will be my final answer. Now your book, again, your book would make it look like S minus 2 pi r squared all over 2 pi r. So let me write that so you see what they're going to, oops, excuse me, not S. It would be H, because that's what we were solving for. They're going to make it look like H is equal to, and the numerator is S minus 2 pi r squared. And then in the denominator, they're dividing by 2 pi r. And that's what they're going to leave it looking like in most cases. We do not want to cancel this with this because, again, there is no canceling in addition. And so that would be their final answer. And the final answer I have, you have to see that there are two separate